All right, Al, so here's the promised example. We're going to be looking at kinematics of an object in free fall, all right? So we introduced free fall, we introduced the idea of gravity and a constant acceleration of 9.8 for anything that's falling in the air. This includes anything falling in the air, anything going up in the air. As long as there's nothing else touching it, gravity is the only force that's acting on it, then it should have that vertical acceleration of 9.8 meters per second squared. Negative if we're going to define it as down. So that's going to be really helpful as we look at these next few problems. All right, so here's our situation. We've got a stone being thrown from the top of a building. The building is 50 meters tall. They give us the initial speed of it. Okay, so we're talking about as soon as it leaves the hand of the person, right? We're not talking about that time when it's in the hand. That's not part of this question here. As it's released, it now has a velocity of 20 meters per second. Now it's being thrown straight upwards, so it's going to go straight up, and then it will come straight back down. It'll pass the building and go all the way down to the ground. All right, now one of the best things to do in a situation like this is let's draw a picture, because the picture is going to help us as we go forward. So here's the building, here's my person. We are going to throw the ball up. It's going to go up to the top, and then it's going to go straight down all the way down to the ground. Now, I do know the height of the building is 50 meters from the ground to the top. So I'm going to go ahead and mark that. And I do know that the velocity right here at the beginning when it's released, that velocity is equal to 20 meters per second. So that's going to be helpful as well. But at this point, we now need to look at the questions to determine what our initial and final points are going to be. You may remember that we talked about in class that when we say final velocity or final position, it doesn't have to be the end of everything, right? It could be just some other point. Same thing could be true of the initial. This doesn't have to be our initial point. We could start up at the top and then end down here. You can do any number of initial and final points. It's just one point is earlier than the other one. Those points, defining those points is going to be really important as we start to answer these types of questions, all right? So the first question is, how much time does it take to get to the maximum height? All right, well, I have some information about the point where it's being thrown, so I'm going to call that my initial point, and then I'm looking for information about the very top, so I'm going to call that my final point. So that's my initial and my final there. All right, now I'm going to go ahead and put together our table so we can see what information we have. Now, hopefully you're reading this question and you're like, oh yeah, I've got a speed, it's asking me about time. I know that the object's in the air, which means it's free fall, so I know some acceleration stuff there. So hopefully you're already thinking, yeah, this is probably kinematics question. So we've got x naught, x, v naught, v, a, and t. So we go ahead and put that in our table, and what information do we have? Well, easy right off the bat, we know the initial velocity right here when I release it is going to be 20 meters per second. All right, now my final velocity, remember the final position is going to be when it's up here at this point. And so that's at the very top, and at that very top there's going to be an instant, not a quarter of a second or a millisecond, not even a millisecond, but it's going to get up to that point. At that point, the velocity at the very top is going to be 0. That should make sense. It's changing from having a positive velocity to having a negative. And what's between positive and negative? 0. So we've got a 0 velocity for the final. Okay? Now, we also know the acceleration. Okay? Because once it's in the air, nothing else is touching it except for gravity pulling down on it. So therefore, the acceleration is going to be negative 9.8 meters per second squared. And I did put a negative in front of it because I defined the initial velocity upward to be positive. So therefore, the acceleration must be negative. All right. Now, you could put in an initial position if you wanted. You can define 0 to be anywhere you want. Okay. In one of the classes we discussed, well, I could make this 0. That means my initial position would be a positive 50. It would be 50 up in the air, and that's fine. All right. You could also define the top of the building to be 0. What that would mean is if you ever need to define the bottom, that would then be negative 50 because it's below your 0 point. And you can do that. The other thing is, at some point, it is going to ask for the maximum height. That's the maximum height from the ground, which means if I define this as 0, I'm going to end up having to add 50 onto whatever I have. So think in advance of what you want to define for your 0. Sometimes making 0 up here will simplify the question for you. It'll make it a little bit easier to solve. Sometimes it makes it a little bit harder. So think about that. That's one of the things to consider as you're deciding how to set up your problem. Okay, right now I'm going to go ahead and I'm going to say that this is 0 just because I like the ground to be 0. So I'm going to start with a height of 50 meters. All right, now this right here does say I want the time to the maximum height. So I'm looking at my information here. I don't have that maximum height yet. I don't know what that maximum position is. So I'm looking at my equations over here. I'm thinking, well, I don't know x, so I really don't want either of those equations that has the x in it, because I'm supposed to be finding the time. I don't really care about x, and I don't have it. So let me try to avoid those, which leaves me with the first equation here. V equals V naught plus AT. So I'm going to go for part A. All right, so V equals V naught plus AT. I do have V, which was 0. I have my V naught, which was 20. This is a plus. Notice how I've come to the point where my T has the little curve on the end. That way I don't mix up my pluses and my T's. My acceleration, I'm going to put in the negative 9.8. And then my time then is T. And at this point, I should be able to solve for T. I'm going to subtract the 20 to the other side. And then I'm going to divide by the negative 9.8. And if I do that, I should get 2.04. So my time is going to be 2.04 seconds. There we go. That was pretty straightforward. All we had to do was draw a picture and create the table. Now we're ready to move on to letter B. Now letter B is the maximum height. So to find the maximum height, I can still use the same initial and final conditions. So I can still use this data right here. But instead of just having T, I also have the T, which is now 2.04 seconds there. And so now I can use any equation I want to be able to solve for x. And so what equation do we want to use? Well, it doesn't really matter. A lot of people will say, well, yeah, but this one already has x by itself, so I want to use that one. Okay, fine, use that one. We'll go ahead and use that one. So for letter B, we can use the same information, but we'll go x equals x naught plus v naught t plus 1/2 at squared. The final position is what we're looking for. Remember, I used 50 for my initial. My initial velocity was 20. I do have the time now, which is 2.04, plus 1/2 times a, which is negative 9.8. And then times t squared, which is at 2.04 squared. Do not forget to square that. That's a lot of times I see things like that where people forget to square that. So we go ahead and punch that in. We got 50 plus 20 times 2.04 plus 0.5 times negative 9.8 times 2.04 squared, and we get that x is 70.4 meters. There we go. So that's letter B. So now we're ready to move on to letter C. Letter C is time for the stone to return to the thrower. Now you may notice that this is now going to require me to look at this point right here. So you have to make a choice. Are you going to make this the initial and that the final? Or are you going to start up here? We have some information about that now, right? We know a height, we know a speed. You could start there and end here. It's totally up to you. You can use any initial and final point as long as one of those points is the point that you're trying to get the information for. And I'm trying to get information for when it gets back to the thrower. Either way, this table right here is not going to help us anymore. Okay? We can still use that information, but only at those specific points. Okay? Now, to make a point, I'm going to go ahead and just use the initial throw. That position is going to be my starting point. And then this is going to be my final. Okay? So, I'm going to need a new table. So, you know, this is a new situation. Let's go ahead and draw a new table here. So we've got x naught, x, v naught, v, a, and t. All right. So x naught, I'm going to define that as 50. It's still going to be 50 there. So I'll put 50 meters there. If you did 0 before, you can put 0 there. In fact, you can change now. If you wanted to change that to 0, that's fine, because we're creating a whole new table with whole new information. So if you wanted to redefine this level as 0 now, be my guest. Go ahead and do it. So 50 meters, the final height, so if it goes up, this is my final height right here, then it's back to 50 meters. So I'm going to put 50 meters there as well. My initial velocity is the velocity when it's thrown up. So that's the 20 meters per second. All right. Final velocity, I don't know that. We'll put v there. Some of you may know that, but I'm going to go ahead and just assume I don't know that. Acceleration. Acceleration is negative 9.8 because from the time it leaves his hand, the only thing acting on it is gravity. That's free fall, so your acceleration is negative 9.8 meters per second squared. And then your time, we do not know the time. So the question is, what is the time for the stone to return to the thrower? So I'm looking for t here. I would love to be able to have a t that does not involve v, since I don't know the final velocity at that point. So not this one, not that one. I'm going to try for this one right here. All right. So we're going to go x equals x naught plus v naught t plus 1/2 at squared. So my x will be 50. So this is part C. So we'll go 50 plus, 50 equals 50 plus v naught, which is 20, times t, plus 1/2 at squared. So we'll go 1/2 times negative 9.8. Don't forget it needs to be negative, times t squared. And hopefully we'll be able to solve for that. All right. So we'll subtract the 50 over to the other side. So we'll have 0 equals 20t plus, I'm going to go ahead and multiply the 1/2 times the negative 9.8. So that's going to become a negative 4.9 t squared. Now, at this point, you could use your calculator to solve that, right? You could use your calculator and it'll solve that for you. If you don't know how to do that, come ask me. I'll help you out with it. Or we can just do a factor, right? We just go 0 equals t times 20 minus 4.9t. And now I have two things that multiply together to give me 0. Therefore, either t equals 0, which that would make sense. It's going this speed and has that position at time 0. But I'm looking for this other one, so I need to solve for the other one here. So I'll say, okay, well, if 0 equals 20 minus 4.9t, what do I get? And so I'm going to go ahead and solve for that. We'll subtract the 20 to the other side, move the 20 over, then we'll divide by the 4.9, and we'll get a time of 4.08 seconds. Now, some of you very astute folk are saying, wait, but the time to the top was 2.04, and the time up and down is 4.08, so does that mean it was 2.04 up and 2.04 down? Yes, sir! That totally makes sense because the displacement's the same, the acceleration's the same, right? Then everything else given that this has to be true, with the information we have, it should mean that the time up and the time down are exactly the same, right? You have the same amount of displacement there, you have the same acceleration there, you're going from a speed to 0, and then you're going from a 0 to some speed, so it's got to be the same if the acceleration's the same. So end up getting t equals 4.08 to the time that it comes back to the thrower. All right, now letter D asks for the velocity of the stone when it returns. Now again, some of you may have already figured this out, but if not, that's fine. We can go ahead and put in our time of 4.08 seconds there, and now I just need to solve for the velocity. You can use whichever one you want, but be careful, right? If I were to, it doesn't matter because no matter what I do, I'm going to go ahead and, I'm going to use the last one. We haven't used the last one yet. The last one looks like fun. I know you're saying, but it has squares, Mr. Bauer. I don't care. It looks like fun to me. So here we go. We're going to try letter D. We're going to do v squared equals v naught squared. Now that initial velocity was 20. So 20 squared plus 2 times a, which is negative 9.8. times x minus x naught, which would be 50 minus 50. Okay, now what's going to happen there? Well, 50 minus 50 is 0, which means that 0 times all this, all that term is going to be 0. That's all going to go away. See, I was smart. You thought I was trying to make things difficult for you, but I was being smart here. So now we've got v squared equals 20 squared. So v squared equals 400 be careful here. How do I solve? I square root. But anytime I square root, the answer could be positive or negative. So it's either plus or minus. A lot of you don't get to this point and be like, oh, it's 20. No, because remember, velocity has direction. And if velocity was 20 meters a second here going up, it cannot be positive 20 here. It's got to be going down. It'll have the same magnitude. That's what we just found. Velocity will be either positive or negative 20. And in this situation, it's got to be the negative because it has a downward direction there. And so D, what speed is it going when it returns? It's going to be going negative 20 meters per second, which the speed then is just 20. All right, so that's A, B, C, D. I'm going to erase this, and then we'll do E, F, and G. So I left our picture up there. Everything else is erased. We're moving on to letter E. The question now is, what is the velocity of the stone at t equals 5 seconds? Now, where is t equals 5 seconds? Well, it's somewhere along this path. We do know, remember in the last question we found that this was about 4 seconds. So t equals 5 is likely to be somewhere a little bit further. Where exactly? Who knows? Doesn't matter. Somewhere around there. Okay, so this is a new final position. Again, you could choose your initial to be here. You could choose your initial to be there. You could use your initial to be there, as long as you use the information that you have for that point. I'm going to go ahead and still use the initial point here, just because it's easy to use the information that we have at that point. So, new table, new point, new table. So x naught, x, v naught, v, a, and t. So our initial position, I'm going to keep that as 50. I've been consistent with that, so I'm just going to go ahead and leave that as 50 meters. I don't know how high it is there, so the initial velocity is still going to be 20. Okay, if you choose a different starting position, then it shouldn't be 20. It should be something else. My final velocity, I don't know what it is at that point, so I'm just going to kind of put a dash there. I don't really know. The question is, what is the velocity at that point? So we're going to go ahead and put a v there to remind us that's what we're looking for. The acceleration, remember, once it leaves the hand, acceleration everywhere then is negative 9.8 meters per second squared. And this time they actually give me the time. They tell me the time is 5 seconds. So we're going to go ahead and put in 5 seconds there. So looking at the information we have, again, we don't have x, so I'm going to avoid the x. So not this one, not that one. So we're going to go with the v equals v naught plus at. And the v is going to be our unknown this time, so that's a little bit different than some of the previous ones. We've got v naught, which is 20, plus the acceleration, negative 9.8. And this time I have the time, which is going to be 5. I should then be able to plug those into my equation and figure it out. Here we go, 20 plus 9.8 times 5. This time I didn't even need to rearrange anything, right? And that's okay, it happens. So I end up getting v, this is v, so v equals negative 29 meters per second, which makes sense, right? Remember, at this point it was negative 20, so if it's falling more, it should accelerate more, so it should have a higher speed. And that's what I got, that v is negative 29. I am putting the negative because this one does say velocity, and so velocity, I need to make sure I have that direction on there, and the negative means downwards, okay? All right, moving on to letter F. Letter F now changes the point again. It says, what is the velocity of stone right before it hits the ground? Okay, so now we're all the way down here at the ground. Again, we're going to go ahead and change so that we can make sure that we're looking at this point, not that point right there. And so again, we'll do initial and final. Again, your initial can be any of these points. You can choose that point. You can choose when it was here. You can choose the one that we just did. Any of those can be your initial, because all of those are going to be along the same arc. They're all going to follow the same physics. It doesn't matter. Again, I'm going to go ahead and use the first point just because that's the one I've been using. And I'm going to do right before it hits the ground. So essentially at the ground, but not. Okay? I know, totally makes sense. Get over it. All right, moving on. We're going to go ahead and make a new table. X naught, X, V naught, V, A, and T. My initial position is going to be that 50 there. 50 meters. My final position, this time I know it, right? All the other ones I didn't know, but now I'm right here, right at the ground. That's what I defined my 0 as, so I'm going to put 0 there. My initial velocity is still that 20 meters per second. My final velocity, I don't know. That's right before it's the ground. That's what I'm looking for right now, so I'm going to go ahead and put the v there. The acceleration is still negative 9.8, so it looks like I have most of the information. I don't have time. I don't know what time it is before it hits the ground. It looks like I'm going to do that in letter G. So letter F, we can go ahead and solve. This time we're solving for v. We don't have t, so we're going to try to avoid something that has t. That's both of those, so nope, nope. We're going to go with this one. So we'll go v squared, which is what I'm looking for, equals the initial velocity, which I'm going to put in as 20 squared, plus 2 times a, which is negative 9.8, and then times x minus x naught, which is going to be 0 minus 50. It is important that you do that, that you put the final, or sorry, the final minus the initial there, so 0 minus 50. What you'll notice then is I'm going to end up with v squared equals 400 plus, can't do that one in my head, sorry. So 2 times 9.8 times, negative 9.8 times 50. And I get 980. This is negative, that's negative, going to end up giving me a positive. I add it to the 400, and then I should be able to square root it. And I get, there we go, 37. So I end up getting v equals 37.1 meters per second. Okay, now it is downward. Remember, when I square root, it can be positive or negative. At this point, because I know it's down here moving downwards, I should go ahead and make sure that it has that negative 37.1 meters per second, and that'll be your final speed right before it's the ground. Again, that makes sense. It's a little faster than this. It's had a little bit more time to accelerate downwards, so it should be a little bit higher than that one, which it is. I'm okay with that answer. All right, last question here. What is the total time the stone is in the air? And so now we're looking for time. Same position, right before it's the ground from release. This one you really do want to use this as your initial. If you use this, you're going to have to add on the time previous, but you can do that, right? So this is why I chose to use that point. Now I can just find the total time. And so again, I'm going to go ahead. You can use any of the equations now as long as it has time in it. So either of these two. I am going to choose this one. It just looks a little bit easier, right? I don't really like the fact that the time here is squared. So we're going to go ahead and go with that one right there. So we'll go final velocity, which we just found, negative 37.1, is equal to the initial velocity, which was 20, plus the acceleration, which is negative 9.8, times time. And now we should be able to solve. So we'll take that negative 37.1, and then we will subtract the 20. Okay, there we go. Negative 37.1. Then we will subtract the 20. And then we will divide by the negative 9.8. And hopefully you get that time equals 5.83 seconds. All right, just like that. Again, remember it was 4 seconds here. Takes a little bit more time to get down to the bottom, so it makes sense that it's a little bit bigger than 4 there. There you go. We've worked through all of these questions. Recognize that anytime you change your initial and final points, you need to create a new table for that information. Don't include information from other points, only your initial and final points. If you'll do that, the math will always work itself out. These equations understand vectors. They understand it's going to go up and down, right? Your math can understand a parabola, right? So that's all included in there. So as long as you make sure to include the right positives and negatives and things like that, you put the right initial conditions in, it's all going to work out for you. Okay? So hopefully that was helpful. Hopefully you got through a bunch of different questions, looked at a bunch of different situations. Of course, you could go through and choose different initial conditions for many of those, and then you would be able to use a different set of equations and different starting points. So that's completely fine. All right? In fact, I encourage you to try that to see if there are other ways that are easier for you. Anyway, that's it for today, and I'll see you next time.